Okay, mathematics class, training you to excel. Welcome. Okay, mathematics class. Step to exam success. 1. Plan. 2. Pray. 3. Prepare. 4. Preview. And number 5. Perform. Please support this channel by subscribing, give a thumbs up, and share with friends. We are looking at WAEC May June 2010, questions number 6 to 9. Question number 6, plane geometry, areas and perimeters of rectangles. Question number 7, number and numeration, percentage profit, import duty, and sales tax. Question number 8, plane geometry, construction. And finally, for this presentation, question number 9, plane geometry, trigonometry, precisely bearings and distances. We go straight to question number 6. The scale of a map is 1:20,000. Calculate the area in square centimeters on a map of a forest reserve which covers 85 kilometers squares. B. A rectangular playing field is 18 meters wide. It is surrounded by a path 6 meters wide such that its area is equal to the area of the path. Calculate the length of the field. Let's see how we can solve this problem. 6a. Area of the forest on ground is 85 square kilometers. But 1 kilometer is equal to 1,000 meters, which is equal to 100,000 centimeters, and which is equivalent to 10 raised to the power 5 centimeters. Therefore, 85 square kilometers will be equal to 85 times 1 kilometers times 1 kilometer. Therefore, 85 kilometers squared is equal to 85 times 10 raised to the power 5 times 10 raised to the power 5 square centimeters. Let the area on map be represented by x square centimeters. Therefore, taking the ratio of the two, x is to 85 times 10 raised to the power 5 times 10 raised to the power 5, which is equivalent to 1:20 all squared. Converting ratio to fraction, x over 85 times 10 raised to the power 5 times 10 raised to the power 5 will be equivalent to 1/20,000 all squared. Making x the subject, we have that 85 times 10 raised to the power 5 times 10 raised to the power 5 is equal to 20,000 multiplied by 20,000. Dividing out and dividing out again, we have x is equal to 85 times 5 times 5. Therefore, x is equal to 2,125 square centimeters. Question number 6b. This is the part surrounding the rectangular field, while the middle here represents the rectangular field. The thickness of the part is 6 centimeters. The width of the field is 18 meters and the length is x meters, and the width of the part is 30 centimeters, and that's obtained by adding 6 and 18, giving us 30 meters squared. While the length of the field, the width is 6 plus 18 plus 6 is equal to 30 meters, while the length of the field is equal to 6 plus x plus 6, and that will give us 6 plus x plus 6. So length is equal to 6 plus x plus 6, which is 12 plus x. Area of the field is given by the length x multiplied by the breadth 18, which will give us 18x. Area of the part surrounding the field will give us the area of the big rectangle minus the area of the field, which is a small rectangle. That's the field subtracted. So area of the part surrounding the field will give us 30 into 12 plus x, the area of the big rectangle, minus 18x, the area of the inner or small rectangle. Area of the part is equal to 360 plus 30s minus 18s. That is removing bracket here, removing bracket here. Then on further simplification, area of the part is equal to 360 plus 12x. But the area of the field, we are told, is equal to the area of the part. So equating the two, 18x will be equal to 360 plus 12x. Simplifying, I have 18x minus 12x is equal to 360. Simplifying further, 6x is equal to 360. Dividing both sides by 6, x is equal to 60 meters. Therefore, the length of the field, x, is equal to 60 meters. That gives us the solution to question number 6. Let's move to question number 7. Question number 6c. The diagram shows a circle center O. If angle POQ is equal to x degrees and the diameter of the circle is 7 centimeters and the area of the shaded portion is 27.5 centimeters squared, find, correct to the nearest degree, the value of x. Let's see how this can be solved. We copy the diagram and label. That's the angle given, the angle at the center for the shaded sector, while x is the angle at the center for the unshaded part. Now, the area of the sector is given by theta over 360 times pi r squared over 1. Replacing a by the area of the sector and making substitution for the radius of the sector, which is 3.5 centimeters. On simplifying, we get that 27.5 is equal to theta over 360 multiplied by 269.5 over 7. Further simplification leads to this. Then we are going to cross multiply. 27.5 times 2,520 will be equal to 269.5 theta. Rearranging the equation and making theta the subject, we have theta is equal to 27.5 times 2,520 all divided by 269.5. Using calculator to evaluate this, we are going to get theta is equal to 257.14 degrees. Theta plus x is equal to 360, angle at a point. Therefore, 257.14 degrees plus x is equal to 360 degrees. Simplifying further, we have x is equal to 360 degrees minus 257.14 degrees. So x is equal to 102.86 degrees. X is equal to 103 degrees to the nearest degree. Then we move straight to question number 7. Question number 7. Madam Kwekiyawa imported a quantity of frozen fish costing Ghanaian cedi 400. The goods attracted an import duty of 15% of its cost. She also paid a sales tax of 10% of the total cost of the goods, including import duty, and then sold the goods for GHCD worth 660. calculate her percentage profits. Let's see how this problem can be solved. The cost price after duty will be 115 over 100 because the cost before the import duty is 100%. And import duty, you can see, is 15%. Adding 15% to 100 will now give us the total cost after import duty as 115 over 100 times 400. Then after paying the sales tax, the total cost of the goods will be equal to the import duty and the sales tax all put together. Therefore, the total cost will be 110 for the sales tax and then 115 for the import duty, then multiply by 400 over 1. All will be divided by 100 and also by 100. On simplification, this will give us 1.1, this will give us 1.15, and this will give us 400. Then multiplying out, we are going to have that the total cost in GHCD is 506. Therefore, profit will be 660 minus 506. Therefore, profit will give us 154 CD. Profit percent will be equal to profit divided by the total cost times 100%. Profit is 154 divided by the total cost 506 multiplied by 100%. Therefore, profit percent using calculator to evaluate this will give us 30.43 degrees. Profit percent to three significant figures will give us 30.4 degrees. Question number 7b. In a school, there are 1,000 boys and a number of girls. The 48% of the total number of students that were successful in an examination was made up of 50% of the boys and 40% of the girls. Find the number of the girls in the school. Let's see how this problem can be solved. Total number of boys in the school is 1,000. Total number of girls in the school, let's represent it with X. Then total number of students in the school will be 1,000 plus X. Total number of successful students in that school will give us 48% of the total number of students. And remember, the total number of students is 1,000 plus X. Total number of successful students who are boys will give us 50 over 100 times 1,000. On simplifying, total number of successful boys will be 500. Total number of successful girls in the school will be 40 X over 100. Remember, X is the total number of girls in the school and 40% of them were successful. Total number of successful girls in the school in decimal will give us 0.4x. Therefore, 48% of the total number of students given by this will be equal to the total number of boys that are successful plus the total number of girls that are successful. Simplifying, 48 over 100 is 0.48 in decimal. With bracket open, 1,000 plus S bracket closes is equal to 500 plus 0.4x. Removing brackets and then collecting like terms. Subtracting, 0.08x is equal to 20. Use your calculator to divide through. X will give us 20 over x. Using calculator here to divide this, will give us x is equal to 250. So therefore, the total number of gears in this particular school is 250. Move to the next question. Question number 8 is on construction. Using a ruler and a pair of compasses only. A. Construct a quadrilateral PQRX with PX is equal to 6 centimeters and angle RSP is equal to 90 degrees and side RX is equal to 9 centimeters, side QR is equal to 8.4 centimeters and side PQ is equal to 5.4 centimeters. Number 2. Construct the bisector of angle RSP and angle SPQ to meet at X. Number 3. Construct the perpendicular XT to meet PX at T. 8b. Measure the length or the side XT. So now, to solve this problem, the first thing we need to do is make a good sketch of what we want to construct. That will help us to do a better construction. So this is the sketch, and this sketch is what we are going to try to construct. Then we'll move to the drawing board to carry out the construction. This is our drawing board. Let's begin the construction now. We draw a line. Use a ruler. Measure out the length RX to be 9 centimeters. With compass at X, draw an arc. With a compass at the point shown, draw another arc. With a compass at the next point being shown now, draw a second arc to intercept the first one. Draw a line to pass through S through that point. That gives us angle 90 degrees. Then we are going to draw our line. Then measure SP to be exactly 6 centimeters. At P, and draw another arc to intercept the first arc. Join the two arcs with a straight line. So we now join from R to P to complete the quadrilateral. That gives us the quadrilateral we are asked to construct. With the compass at the point shown, we draw an arc. Draw another arc by setting the angle RSP. Now, with the compass at P, we draw another arc. With the compass at the point shown, we draw another arc. With the compass at the next point, we draw another arc. The two arcs will intersect as shown. Draw a line to pass through them. The point of intersection of the two lines or the two loci constructed is at X. So now that is the point. Then with that point, compass at X, open to any radius of your choice, which will be greater than the perpendicular distance from X to the line PX. That's the arc. Now, with the compass at this point, open to the radius, giving us at least half of the length of PX, draw an arc. And with the compass at the point here, draw another arc. Then join from X to that, the intersection of the two arcs. That gives us a line that is perpendicular from X to the line PX. So that point is T. And that is represented by the green line. We measure the length XT. XT is equal to 3.7 centimeters. We are done with the construction. We'll move to the next question. Question number 9. In the diagram, side AB is equal to 8 kilometers, side BC is equal to 13 kilometers. The bearing of A from B is 310 degrees. Calculate correct to trace significant figures: A, the distance AC; B, the bearing of C from A; C, how far east of B C is. Now let's see how we can solve this question. We copy the diagram as given in the question, putting the distances indicated. Now the bearing of A from B from C is 230. That's being represented. The remaining part of the angle here should be 230 minus 180. So therefore angle BCX is equal to 230 minus 180. That will give us 50 degrees. That's the angle shown here. Now this angle is equal to this angle. You can see them having the same color represented. That is the alternate angles. So angle NBC is equal to 50 degrees, alternate angles. Now this angle here, starting from the north, is 310 degrees. The remaining angle that complete 360 is the one highlighted in magenta color. Therefore, angle ABN plus 310 degrees is equal to 360 degrees, point angle. So angle ABN will give us 360 degrees minus 310 degrees, and that will give us 50 degrees as shown. So that's the diagram so far we have reached on the other slide. We just copy it to the new slide to continue our working. So we need to find that angle. That angle will give us the 50 degrees we have calculated using this, and the 50 degrees we calculated using the angle at a point. So therefore, angle ABC is equal to 50 degrees plus 50 degrees, and that is 100 degrees. So AC squared is equal to AB squared plus BC squared minus 2AB times BC cos B. So we are aiming to find the side AC. So AC will give us A squared plus 13 squared minus 2 times 8 times 13 cos 100. AC squared will give us 64 squared plus 169 minus 208. Then cos 100 will give us minus 0.1736. On further simplification, AC squared will give us 64 plus 169 plus 36.12. Remember the two minus here, we multiply themselves to give us plus. AC squared is equal to 269.12. Take the square root of both sides. AC will be equal to 16.4 kilometers. Then we'll move to question number B. To find the bearing, we need to calculate angle C. So sine C over 8 is equal to sine 100 over 16.4. So sine C is equal to 8 sine 100 over 16.4. That's making sine C the subject, so that we'll be able to find the value of angle C. So therefore sine C will be equal to 8 times 0.9848 over 16.4. Sine 100 is given by this. Using calculator to evaluate this, we are going to have that sine C will be equal to 0.4804. Therefore, angle C will be equal to 28.71 degrees. So that gives us angle C. So now therefore the bearing we have to calculate is shown all in this color here. So therefore angle ACS is equal to 50 degrees plus 28.7 degrees, and that will give us 78.0 degrees. Remember, angle ACS. And that angle ACS is equal to angle NAS, alternate angles. Angle NAC is equal to 78.7 degrees, alternate angles. Like I said, this angle here is equal to this angle. So this and this are alternate angles. Therefore, the bearing of C from A is equal to 78.7 degrees. Now, we want to solve the last question in this presentation. We want to find how far east is C from B. Now, you can see the triangle in green. That's what we are going to use. We are interested in finding the length BX. So, distance of C east of B is equal to BX. That's BX here given. So therefore, applying simple trig ratio, BX over 13 is equal to sine 50 degrees. And that's what we have here. Cross multiplying, side BX is equal to 13 sine 50 degrees. Sine 50 is equal to 0.7660. So therefore, BX is equal to 9.958 kilometers. BX is equal to 9.96 kilometers to 3 significant figures. That's the solution to question number 9 and the last solution for this presentation.